Now let's build on the elements we've introduced so far to analyze some ordinary propositions. Let's start with the elements. Okay, we've talked about subject of the proposition. We're going to consider that an argument that is put in the predicate, which we will treat more or less like a function. So let's take an example. The example that we've used so far, Matthew has a headache. We can analyze. That says headache. We can analyze into a subject or the argument. This is the argument. And if you take the argument out of this proposition, you have basically a function left. So let's let h of x is just a placeholder, stand for blank has a headache. So, as we said in the previous tutorial, if we treat this as a function, then we can put a value into that function. In this case, we're going to put the value into the function to generate the complete proposition, Matthew has a headache. So we would write that as h of m. Now, analyzing propositions in this way into subjects and predicates allows us to represent some internal structure inside propositions, while at the same time we take advantage of the operators from propositional calculus. So let me illustrate that. Suppose we have the proposition, Matthew is hungry and has a headache. So, is hungry and of course the subject repeats, Matthew has a headache. So in English we often have compound predicates, compound subjects. They're often joined together with connectors that will be familiar. So for instance, you might say Matthew or Don will do the logic tutorial. That's a compound subject. In this case, Matthew's hungry and has a headache is a compound predicate. But what we actually mean when we use those compounds is to be providing complete assertions about the world, or in other words, individual propositions that are joined together with connectives. So have a look at this. Matthew's hungry and has a headache can be analyzed as the proposition Matthew is hungry, the proposition Matthew has a headache, joined together by the connector and, which of course is ordinary English, but we can formalize that as a conjunction. So if we take the approach that we did above and we represent Matthew is hungry with the function blank is hungry and the argument Matthew inserted, and let's let e of x represent blank has a headache. You'll see why I can't use h again, because it would be confused with this function. So then we have e, and the argument that is inserted there is Matthew again. So now we have our connective. We will use the conjunction, and the result is a formalization of the English sentence, Matthew's hungry and has a headache, into h of m and e of m, where h of x stands for blank has a headache, and e of x stands for, stands for blank is hungry, and e of x stands for has a headache. Now we can extend this technique to all sorts of propositions that are more complex, and essentially just by working step by step we can formalize all the way down to the level of subjects and predicates using our structure from quantification theory. So let's take an example. Matthew wanted to go to the movie but didn't have any money. Okay, so let's get that out. So Matthew wanted to go to the movie but didn't. So here we have a compound subject. It repeats. Matthew didn't have any money. All right. So there's our proposition. So let's begin the process of breaking this down. So essentially we have two propositions. Matthew wanted to go to the movie. Matthew didn't have any money. We can see an operator here. Most likely that's going to be the conjunction, but in English is almost always the conjunction. But look here, we have another operator that we can pull out. That's a negation operator. So the proposition on this side is actually Matthew did have any money. I mean, that's a weird sentence in English, but Matthew did have any money, but it's negated, right? So let's keep that in mind. We're going to have to do something with that negation. So let's start on this side. Matthew wanted to go to the movie. So let's let W of X stand for the predicate blank wanted to go to the movie. So in that case, we can formalize Matthew wanted to go to the movie as W of M. And again, we use capitals to stand for the predicates, sort of like a function. We use lowercase letters to stand for the argument, the subject of this sentence in this case. Okay, so this takes care of Matthew wanted to go to the movie. Now let's look at this. Let's let M stand for blank did have money. So M of X stands for blank did have money. And the argument that goes in is Matthew. So that stands for M of M stands for Matthew did have any money. And then we'll put our negation sign out here in front of this proposition, just like we would for an ordinary schema in propositional calculus. And so the result is this proposition, which we can write Wm, and it's not the case that M of M. So this is a formalization, again, using the elements, subjects, and predicates of Matthew wanted to go to the movie. So there's Matthew, and the function wanted to go to the movie. But it's not the case that Matthew, there's the argument, Matthew had any money. So when you break it down like this, it sounds stilted and strange, but this reveals the logical structure underneath the English sentence, Matthew wanted to go to the movie but didn't have any money. Now, a couple of things to point out here. When we use a variable in this way to define a function, it's like making a dictionary. The X just stands for the blank, and that's because X is a variable. It doesn't actually tell us anything about the value that goes there. It is basically just a placeholder. So another way we could write these definitions is by writing X did have money. Let's make it a little bit closer to English. And why is that? Because X does exactly the same work that a blank does. It's just a placeholder for an argument. Okay, let's do one more example. Let's do this. If Matthew has money, then he will go to the movie. So let's write that down. If Matthew has money, then he will go to the movie. Okay? Oops. It's not moving, movie. All right. So right off the bat, you can recognize that we've got an if-then here. That's a sign that we're probably going to have material implication as the major operator. So now let's analyze the propositions here. Matthew has money, so that's basically the equivalent to m of x. So let's let that be m of m. So that stands for Matthew has money. And now let's map out what he will go to the movie might look like. So let's just use G to stand for G of X to stand for X will go to the movie. Okay? So now again, we want to pick these function abbreviations like M and G. We can't use M for he will go, or for blank will go to the movie, because we've already used M. So we can't repeat that without confusion. So it's easy enough. We'll just use G. So G of X stands for X will go to the movie. So to formalize he, that's Matthew, will go to the movie, we'll use G of M. And so our formalization looks like this. M of M implies G of M. So if you sort of unpack all of this, it means basically, because we have the material implication, if M of M, then G of M. And what does that mean? If Matthew has money, is our argument and the predicate, then Matthew will go to the movie. Again, the argument and the predicate. So this is how we handle compound predicates or compound arguments. Compound predicates will mean that we'll have to use operators to connect them. And when we have compound subjects, we will have to first split the propositions as we did here and here. So Matthew wanted to go to the movie but didn't have any money. We have a compound. Basically, Matthew is repeated, so we have a compound predicate here. So we have to break these down into their different propositions and then continue on with our formalization.